possible to test that the parameter they asked, the air voids, in order to have between 3 and 6%, 3 and 5%, then the in the right-hand side strength. And so we defined that the results obtained from the asphalt plant was in line with the results in the lab before the production. So this is the example of the production we have done. Okay, then okay, this is just an example that of the project we have done. So what's important to say that in functional parameter we want to restore, for example, penetration, softening point, viscosity, PG, at high temperature, fatigue, and low temperature, the dosage of rejuvenator that we want to reuse is different. So it's very important to define which is the parameter that we want to restore, and so which is the dosage. Usually, it's easier to restore the low temperature and the average temperature than the higher temperature. So, for example, in Brno, the university carried out a laboratory test and experimental plan in order to define which are the dosage in function of the parameters. So, for example, in this case, the target was a bitumen with penetration 56 and 48, and these are the main parameters of the BBR, softening point, stiffness modulus, phase angle, and viscosity. So what they've done is to define with our additives with 0, 4, 8, 12%, which is the dosage that we had to use in order to restore this parameter. And it's possible to see that to restore with the BBR parameter is easier, as we saw even in our lab, than the other parameters. This is just due to the effect of the additive in the mixer. So even in this case, they define the curve, that is this one, and in function of penetration, a softening point is possible to define, in this case, the behavior of the material in function of the penetration of the point of the oxidized bitumen we have, and what's happened adding the rejuvenator. This is the research, and it's very important to see this in function of in order to know what's the difference between a rejuvenator and a flux oil. So which are the tests? As I said at the beginning, we know that apparatus is a rejuvenator because we carry out different tests in terms of with the DSR, AFM, and further tests. So this is the experimental plan. We started to say, okay, we are talking about recycling agent. So we gave all our material to the university. They carried out different tests. And these are the parameters they checked with the DSR, loss tangent, G-star, and rating parameter. Then what they've done to see what's the behavior with different dosage with 2, 4, 6%. And so they saw that, for example, the sample number 1, 3, and 7 is as a recycling agent can be a rejuvenators. Okay, the others they are changing too much the rheology of the bitumen, even with 2%. So it means that it can be taken into consideration that is like a flux oil. So that's not just an important parameter to say that for sure it's rejuvenator or flux oil. So what we have done with a Microsoft analysis AFM, we analyzed the structure of the bitumen oxidized. So we have the reference virgin bitumen, we have the PAV bitumen, so after the aging process, and then we have the bitumen with the rejuvenators. What we saw is that you can see here the structure. Okay, this system is increasing because, as we said, the asphaltene are bigger than in the PAV bitumen than in the virgin bitumen. And so what's left of the rejuvenator, the pictures, was the target is to have the same structure. So they said that as we saw with the DSR, sample number 1, 3, and 7, and even number 6 in this case, they are acting on the structure of the asphaltene. Okay, so the effect of the rejuvenator. So why we have to use a rejuvenator? Because it's possible to restore the chemical parts, and benefit in terms of mechanical performance, ITS, load distribution, fatigue resistance, and cracking resistance. So what is possible to do is this further test, rheological XRD and AFM test to check about rejuvenator flux oil. About how to use in the plant is super easy. Text a pump in function of the plant, continuous plant or batch plant. It can be added the system in the asphalt plant. Usually we add it in the bitumen. Why? Because we are not using 100%. With 50%, we prefer to use the bitumen like a vehicle to spread homogeneously the rejuvenator in the mixer. Otherwise, for example, in Switzerland, when we use 100%, after the heating system, we spread on the belt the rejuvenator on the wrap before to add it into the mixer. So it depends the system we are using, the plant, the amount of wrap, we can define the best way how to add it. So these are some examples, and then I finish this presentation where we use, so in the example of Switzerland, 100% of wrap. We have done laboratory tests in terms of curve, properties of the bitumen, and properties of the mixers. In Brno, after the analysis done in the university, they choose our products for the trial section. We use 50% of wrap, and they have done all tests, as I showed you before in the example number 2, about the different parameters that they have to restore, and then they carried out tests even after production. So after extraction, they checked the penetration, softening point, modulus, and MSSCR test. So they checked all parameters in order to see what's the characteristic of the bitumen that they used. Then this is the example in Korea. As I said in the beginning, we use 100% with our rejuvenator. We checked the curve, we checked the type of rejuvenator grade that they are allowed to use in that project. Production temperature around 160, 180, compaction more than 160. Then they check the static performances and the bitumen properties after production. This is the Italian example. This is the asphalt plant from Marini called Master Tower. It's possible to use up to 100% of wrap. In this case, we are using 60%, from 60 to 90. But in this example, 60% where we pave it. So in this case, we're using rejuvenator and warm mix. Why? Because they want to have extra benefits in terms of energy consumption. So they prefer to reduce the temperature of production and to produce it and compact it at dry condition. We check it in this case more for the tests, like, for example, stiffness at 20 degrees, density, voids, rotting resistant, and the curve that they used. And even for the parameters, for example, the static voids parameters. This is another example that we have done in Spain. In this case, the plant is a batch plant, and they use a second dryer system. So they installed, they did a modification of the system. It's possible to see here. This is a dryer used just for the wrap. This is the elevator, the balance, and with this system, it was possible to add 50% of wrap. So we checked first the bitumen properties. So we have done a field analysis on the different cores of these highways. Okay. Then we checked the amount of rejuvenator to add in order to fulfill the local specification about the bitumen after extraction. And then we checked the mechanical performances of the mixer in terms of stiffness, voids, and TSR. And in this case, has been used 50% of wrap. So thank you for your attention. If you have any questions, please let me know.
Okay, thanks for the interesting presentation, Luca. I believe I have 3 questions here. So let me spill it out a little bit. The first one is about the mechanism that you explained previously about how the rejuvenating agent changed the molecular fraction in Sara content in the bitumen by breaking the dense molecular chain of asphaltene, basically, right? And what does it turn into then? I mean, how does it change the fraction system in the Sara molecular in bitumen? Well,
the point is this one. As we said, even to our other clients, it means this is not an aromatic oil. It means aromatic works in that way. So the they change the SARA parameters. In this case, we saw if we are changing what's the asphaltine, because the stiffness and the main problems are connected to the asphaltine. So to have a structure with asphaltine that are bigger, let's say, in that case, the stiffness of the material can be higher. For example, a further test that is not here, that is the last test that we carried out, is that to do a SARA extraction, okay, then of a virgin bitumen, bitumen after PAV, and bitumen after PAV plus rejuvenator, and to split the different composition, different components in the bitumen, and then the asphaltine that's are solid. Okay, we can put this asphaltine on, let's say, on a heating system and check the melting point of the asphaltine. So what does it mean? That if I have a melting point of the asphaltine, not of the bitumen, that is like the softening point, but the melting point of the asphaltine, for example, of a virgin bitumen is 50 degrees. Of the bitumen after PAV is 90 degrees. What's happened with flux oil? With a flux oil, I just diluted the asphaltine, so the structure of asphaltine is the same. So when I do that test, the melting point of the asphaltine are always the same, 90 degrees. Instead, if I use a rejuvenator, what's happened? I destroy this structure that I have. So the dimension and the sides of the asphaltine are like the one was before. So the melting temperature of the asphaltine is lower. Okay, it doesn't mean that it's anymore 50, but it's not neither 90. It depends on the amount of rejuvenator I'm using, and in that case, the melting point can be around 60 degrees. So the effect of the rejuvenator is that one. Is not something that just I remove I spread better the asphaltine and I dilute it, but the effect is on the dimension and the characteristic of the asphaltine that you are using.
Okay, thanks, Luca. And we have the second question here. Is it possible to use your rejuvenator product to modify the characteristic of natural bitumen? For instance, what we have here, Buton product as Buton asphalt. Is it possible to make it softer or make it having a similar properties to that of the neat-based bitumen?
Buton is a latex, no? Butonal you are talking.
Yes, that's one.
Butonal is a modifier, is a latex, so it means SBR. Is another thing.
It's
it means
a Buton natural asphalt. It's a natural asphalt here that we have in Indonesia, or maybe we have other types of natural asphalt like Trinidad or something else. Is it possible to modify those kind of natural asphalts as well?
Well, we never tried it, even because that natural asphalt. Okay, I understand what was that. It's like we call it selenizza. It's oxy. Is a natural bitumen, let's say. Well, we never use in that way. It means so we don't know how it works in that case, because it's another thing. It means we use that. Usually we can use it to change the parameters of the bitumen, but just, for example, penetration softening point, because talking about PG and other stuff, another test that doesn't affect it. So honestly, we never test in that way.
Okay, thank you.
So we don't know.
Yeah, thank you for the answer, Luca. And one last question is that regarding the repeated recycling, is it possible to do, or is it feasible to do with your technology right now, repeated recycling process? In terms of maybe the mechanical and also in terms of maybe environmental burden. Is it possible to do repeated process of, you make it repeatedly. You do it one time and then you do the recycled one, recycling again, etc., etc.
Well, that's yes. The point is that now we are using the wrap that is can be 10, 20 years old. So what will happen? We are doing even further tests about that. It means that I think that in this we have a collaboration with another university, and we are doing tests like this. It means we are trying to understand which is the aging level of the wrap. We are trying to understand the aging level of the wrap in function of the aging level of the mixer, and we are trying even to understand about what's happened about this process, but even about to reuse it. That yes, the problem is that, as I said, that you can see in the effect of the rejuvenator is that you can see the benefits. You have it means after PAV, okay, after RTFT, of course we have a loss of properties, but you fulfill the specification. After PAV, you can see, I think here, after PAV, of course, with rejuvenator, okay, if I want to have the same condition of the virgin bitumen, 50-70, for example, I should add 8%. If I have 8%, I have this condition. Otherwise, what happens? So this is an expression, an idea that if I add just 6%, 4.5 that I used, I should be here as a result. So it means I had to expect that the bitumen I have after 15 years, more or less, to be a little bit, let's say, with softening point, high penetration, higher and lower than of the virgin bitumen that I'm using. So I should add a little bit, maybe a little more rejuvenator to have the same condition. But this is something that we had to define in function of the project and that we have. But of course, you can reuse it. The wrap that with means the mixer that you are producing with wrap, you can reuse it. That for sure is not. The only point is that you have a new wrap source with new properties, because the aging process can be the same. That the wrap passed now in the last year, or it can be a little bit different in the future. So it depends on which is the aging process that will happen in the wrap, and which is the new condition of the wrap you have in terms of bitumen or properties of the oxidized bitumen you have. But yes, you can reuse it.
Okay, great. Luca, we have one more question before we switch to the other presenter, which is about the cost of production. What, in your experience, what do you think about the difference of production cost between the wrap and the normal asphalt mix?
But if you use 50% of wrap now, I don't have here, but you have a reduction in terms of cost for sure. If you have 50% of wrap and you reuse it, you are saving 50% of the bitumen, okay, more or less. So in that case, if in 1 ton you use instead of use 50 kilos of bitumen, you're using 25 kilos of bitumen. Now, if you are saving 20 kilos of bitumen. Now, the cost of the bitumen, I don't know how much is there, but if you take in consideration 500 kilos per ton, okay, so in 1 ton you're saving 25 kilos. So how much is 20 kilos per ton is 0.25 euro per ton is 25. You are saving 60, more or less 60 per ton. So just saving about bitumen. Okay, so you have a cost reduction of the material you're using just for the raw material. Then even the process and everything. So that's for sure you have a cost reduction. It depends on the cost, the bitumen cost you have there, and the amount of wrap you are managing your asphalt plant. But usually you have a reduction. Then if you, for example, if you have more expensive is the nick bitumen you have right now, I think that is it means in Italy is around, as I said, 500 euro per ton. So if multiplied by 45. Yeah, it's around with 500 euro per ton. If you save per ton 25 kilos, you are saving $12, more or less. We are talking. Okay. With the price of the bitumen, $500 per ton. If the price of the bitumen is higher, like it was 2-3 months ago, the cost reduction is even higher in that case. So use RAP is not just its cost benefits, but even very in terms of the life cycle assessment, in terms of environmental impact, in terms of this aspect is a benefit.
Okay.
More or less, we are talking about 10% of RAP. We are talking about 5% saving. 10% of RAP is 50% saving. So it means you have a cost benefit. That's for sure.
Okay, great. Thank you for the nice discussion and an interesting presentation, Luca, and also Antonino there. We wish you a very good night. But yeah, sekarang kita akan lanjutkan Bapak Ibu di Zoom.
Thank you very much.
Yes. I will continue in bahasa right now. Jadi Bapak Ibu peserta di Zoom maupun rekan-rekan yang ada di sini, kita akan melanjutkan dengan presentasi terakhir dari Pak Ari Wibowo selaku dari pihak Jaya Konstruksi. Pak, waktu dan tempat saya persilakan.
Masuk ya? Imam bisa disiapkan? Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore teman-teman sekalian yang di Zoom maupun yang hadir di sini. Sebelum saya perkenalan, saya ingin memulai ini dengan sebuah pertanyaan. Tadi yang disampaikan oleh Mr. Antonio dan Mr. Luca tadi, itu sangat baik, sangat menarik. Pertanyaannya adalah kenapa di Indonesia tidak populer, artinya tidak berkembang. Padahal ini bukan teknologi yang baru kemarin. Saya rasa ini sudah tadi dijelaskan sudah cukup lama, cuma memang kenapa di Indonesia tidak populer. Banyak hal yang menyebabkan itu tidak populer, banyak hal yang menyebabkan itu tidak bisa berkembang dengan baik. Ya, saya sebelum memulai presentasi, ini adanya, Mam. Share screen dari sana aja. Ya, saya akan menampilkan sebuah video pendek tentang PT Jaya Konstruksi dalam hal ini yang terkait dengan pekerjaan hot mix daur ulang. Silakan Imam, bisa? Sebetulnya ada di YouTube, cuma saya ingin menunjukkan pada teman-teman sekalian. Iya, Imam. Ya, Mel ya, kita lihat sebentar ya.
Jalan raya sejak dahulu senantiasa selalu menghubungkan jarak di antara manusia. Ribuan kilometer jalan raya di Indonesia terbuat dari aspal beton yang berbahan baku material alam yang tidak terbaharui dan ketersediaannya semakin langka. Salah satu tantangan kita di masa ini adalah memaksimalkan teknologi untuk menghasilkan jalan raya yang berkelanjutan dengan kualitas terbaik, ramah lingkungan, memperkecil penggunaan material alam, dan hemat biaya produksi. PT PT Jaya Konstruksi Manggala Pratama Tbk sebagai anak usaha dari PT Pembangunan Jaya merupakan perusahaan pelopor di Indonesia yang pertama memiliki pengolahan daur ulang aspal dengan sistem hot recycling dengan lahan seluas 1,5 hektar dan didukung beberapa fasilitas, stok yard material, mesin granulator, Asphalt mixing plant, dan hot recycling plant, dan laboratorium pengujian untuk menjamin mutu pelaksanaan secara konsisten. Layanan satu atap yang ditawarkan Jaya Konstruksi meliputi keseluruhan proses konstruksi jalan raya. Proses pengerukan aspal lama dilakukan menggunakan cold milling dan menghasilkan reclaim aspal pavement atau RAP yang menjadi salah satu material dasar untuk membuat aspal beton dengan sistem hot recycling. Mesin granulator memisahkan agregat kasar dan agregat halus dari reclaim aspal pavement dengan cara melepaskan butiran agregat dari lekatan aspalnya tanpa memecahkan butiran agregat kasarnya sehingga menjamin homogenitas gradasi campuran yang dihasilkan. Reclaim aspal pavement dipanaskan di recycling drum dengan menyalurkan udara panas ke dalamnya. Cara ini dilakukan untuk mencegah terbakarnya aspal yang terkandung dalam reclaim aspal pavement sehingga aspal tersebut masih berfungsi untuk mengikat butiran agregat. Reclaim aspal pavement, fresh agregat, dan aspal bitumen dicampur dalam kondisi temperatur yang sesuai dengan persyaratan. Proses ini akan menghasilkan homogenitas dalam campuran seperti pada aspal beton fresh. Aspal beton hasil produksi dapat disimpan di hot silo dengan kapasitas 2 kali 200 ton. Aspal beton juga dapat langsung dimuat ke dump truck untuk dibawa langsung ke lokasi penggelaran. Pengendalian proses produksi dilakukan secara full automatic dari dalam operation room menggunakan program yang diatur sesuai dengan job mix formula sehingga campuran aspal beton yang dihasilkan akan memenuhi spesifikasi yang diinginkan. Dilengkapi CCTV untuk memastikan seluruh komponen proses produksi berjalan dengan baik. Dump truck yang telah terisi aspal beton ditimbang pada jembatan timbang. Kemudian dilakukan pengecekan temperatur, pengambilan sampel aspal beton untuk uji mutu di laboratorium. Penutupan dengan terpal dilakukan untuk mempertahankan temperatur tetap tinggi dan mencegah air hujan masuk ke dalam bak truk. Setelah proses tersebut, aspal beton siap dibawa menuju lokasi penggelaran. Proses penggelaran dan pemadatan aspal beton dikerjakan dengan penuh ketelitian untuk tetap mempertahankan kualitasnya. Jaya Konstruksi berusaha menjadi perusahaan terdepan dan lebih peduli terhadap lingkungan. Inovasi teknologi pada HRP kami dapat menghemat pemakaian bahan bakar. Debu batu hasil pembakaran ditampung dan digunakan kembali sebagai bahan filler yang dibutuhkan dalam campuran aspal beton. Penggunaan material reclaim aspal pavement akan mengurangi pemakaian fresh material sehingga dapat menekan biaya produksi. Komitmen Jaya Konstruksi ini ditunjang oleh sumber daya manusia yang berkualitas, kompeten, dan profesional. Dengan pengalaman lebih dari 40 tahun dan berbekal standar sertifikasi ISO 9001, ISO 14001, OHSAS 18001, Jaya Konstruksi telah banyak berperan pada pembangunan infrastruktur jalan raya di Indonesia. Hot Mix Recycling Plant adalah usaha kami untuk menjadi lebih baik. Menghasilkan aspal beton bermutu tinggi sesuai standar, memanfaatkan kembali aspal lama sebagai material daur ulang, dan menggunakan lebih sedikit fresh material sebagai wujud peduli lingkungan. PT Jaya Konstruksi Manggala Pratama Tbk selalu berupaya untuk memberi yang terbaik pada ribuan kilometer jalan raya di Indonesia.
tadi pertanyaannya kenapa recycling tidak berkembang? Nanti akan ada banyak materi yang bisa kita lihat. Kenapa recycling ini bisa tidak berkembang baik? Tapi tadi dari pertanyaan yang muncul ada yang menanyakan tentang cost biaya. Tadi kita agak terus terang kami yang sudah berkecimpung gitu ya. Kita agak susah menilai biaya itu karena memang secara komersil gitu bedanya tidak terlalu signifikan, sehingga tadi ditanyakan itu kenapa biayanya seperti itu. Kalau dari kami menjawab, nanti bisa kita lihat bahwa pemakaian alatnya berbeda, tidak seperti AMP biasa. Kemudian materialnya ada rejuvenator yang juga berbeda. Tetapi dari sisi yang lain tadi, yang dari segi sisi lingkungan, kemudian sisi polusi, kemudian dari penggunaan batu, itu mesti akan lebih menguntungkan. Jadi secara jangka panjang lebih menguntungkan. Baik, saya akan mulai. Ini adalah, kalau saya menyampaikan, ini adalah sharing experience, karena memang ini pengalaman kita yang kita sampaikan, dan terus terang mohon maaf, kami bukan peneliti yang mempunyai data-data yang lengkap, tetapi kami memang melakukan semua proses yang tadi disampaikan, pengujian-pengujian itu kami lakukan semua di lab dan kami sampaikan di sini. Cuma memang kami tidak membuat penelitian. Jadi aspal rap itu kita cek semua kondisinya, aspal yang sudah kita milling itu kita cek semua kondisinya, berapa nanti duktilitasnya, berapa penetrasinya, berapa titik softening point-nya, itu kita lakukan. Tapi memang kita tidak melakukan kajian terus kemudian kenapa seperti itu ya. Nah, mungkin nanti kita bisa kembangkan lagi ke depan. Baik, ini ya, saya menyampaikan ini sebagai sebuah sharing experience. Next. Sebetulnya saya tidak terlalu, next, Mam. Kok nggak mau? Aduh, biasa ini. Laptopnya Imam suka mohon maaf ya. Di situ mau apa enggak di laptopmu, Mam? Oke, ya. Nama saya Ari Wibowo. Saya sebetulnya lebih banyak saya ini bergerak di pengalaman saya di struktur. Di jalan saya memang tidak terlalu banyak, tapi ya saya pernah mengerjakan jalan, ada di Nias, ada di Kalimantan, ada di yang teman-teman ikut ini adalah di Formula E. Tadi kalau di pagi hari di Formula E itu mempergunakan aspal modifikasi. Sayang tadi saya tidak bisa ikut banyak, memang modifikasinya cukup rumit itu. Nah, nanti bisa lain waktu kita bicarakan. Oke, next. Jadi saya ingin bahwa ini ya. Tadi saya ketika masuk ke sini saya bilang sama Pak Kirat, saya paling senang diskusi dengan teman-teman mahasiswa ini. Mohon maaf pada Bapak Ibu yang ada di Zoom. Saya ingin menanyakan, ada yang punya pendapat enggak? Ini itu matahari terbit atau matahari tenggelam? Coba Mas, apa Mas? Boleh? Tenggelam, alasannya apa, Mas? Ayo, Mbak. Matahari terbit atau matahari tenggelam? Saya nggak perlu terbit atau tenggelam, saya perlu alasannya aja kok. Matahari terbit atau matahari tenggelam? Ayo, Mbak. Kurang. Ayo, Mas. Yang pakai kacamata? Tenggelam. Kenapa? Alasannya apa? Oke. Ada yang menjawab matahari terbit? Mbak, itu? Apa? Oke, nanti kita lewati ya. Jadi ini adalah matahari terbit. Kenapa? Bukan kenapa, alasannya apa? Kalau saya membaca di Google, matahari tenggelam itu lebih merah. Nah, ini saya ingin memberikan gambaran bahwa kita itu harus setiap hari menjadi lebih baik, dan ini aspal daur ulang ini adalah upaya kita untuk menjadi selalu lebih baik. Oke, next. Nah ini teman-teman, ini adalah kerusakan jalan. Jadi saya mohon teman-teman kalau melihat kerusakan jalan, jangan berpikir kerusakan jalan itu karena mutunya oleh kontraktor dikurangi. Jangan berpikir itu. Tapi sebagai seorang yang berpendidikan harus melihat dari mana itu kerusak. Bisa saja karena pembebanan yang tadi disampaikan oleh teman-teman dari Buntara tadi, pembebanan yang terlalu berat. Bisa saja karena saluran yang tidak berfungsi, tapi tidak tertutup kemungkinan memang karena pola operasional yang tidak baik. Itu yang menjadi concern saya. Ya, ketika teman-teman melihat kerusakan, marilah kita lihat kerusakan itu secara jernih. Oke, saya next karena saya udah hafal ya anunya. Jadi kerusakan jalan itu bisa terjadi kerusakan dari dalam maupun dari luar. Salah satu kerusakan dari dalam adalah kalau jalan itu tidak dipakai, maka akan terjadi oksidasi. Nggak bisa? Berarti gimana ini? Oh gitu. Akan terjadi oksidasi. Nah ketika terjadi oksidasi, maka aspal lekatannya akan semakin berkurang. Tadi dijelaskan, tadi yang jelaskan siapa ya? Pak Antonio kayaknya, lekatannya akan semakin berkurang sehingga dia akan lebih mudah untuk rusak. Nah ini mudahnya seperti itu. Oksidasi bisa terjadi meskipun tidak dilewati karena waktu. Tadi yang disampaikan karena waktu. Bisa? Bisa Mas? Aduh, mohon maaf ini. Next. Oke ya, tadi kita sampai di kerusakan ini. Jadi nggak apa-apa, lewat aja. Ini ada yang kerusakan karena saluran, ada yang kerusakan karena pembebanan. Nah ini biasanya kita kalau ada penanganan kerusakan itu kita selalu memikir atau yang dihitung pada akhirnya adalah biaya seperti tadi ditanyakan. Ya, padahal itu nanti ada berbagai hal yang harus kita ketahui. Tapi saya tidak mau masuk ke situ. Saya cuma mau mengatakan bahwa seringkali kerusakan itu menjadi parah karena dan menjadi mahal karena keterlambatan penanganan. Penanganan lebih cepat akan mengurangi keparahan dan menghemat biaya. Tolong ini oleh teman-teman, terutama pada adik-adik mahasiswa. Memang kita harus bergerak cepat. Nah, ya, supaya kerusakan tidak bertambah banyak dan bertambah mahal. Oke, next. Nah, ini ya teman-teman sekalian, saya ingin menyampaikan beberapa daerah itu mengalami kesulitan pengadaan material. Saya sudah bekerja di hampir seluruh Indonesia, di Kalimantan Timur yang notabene itu kaya raya, sekarang mau dipakai untuk ibu kota, itu tidak ada batu. Batu harus didatangkan dari Palu. Ya.